Hey, everybody, welcome back to your Dawn of Autonomy podcast. I'm Don Zolda, your host, CEO of P3 Tech Consulting, and publisher at Autonomy Global. Welcome to the month of October. And if you're a federal employee, I'm sorry you're at home. But hey, if you're watching us, thank you for that. It's going to be a crazy ride here, but it's a new month and it's a new theme. This month, we are focused on the theme of mission enablers. And we are so excited to have this Philadelphia based company on the show. That is my hometown. So shout out for Philly, yo. This is Exyn Technologies, and we've got Brandon. He is the CTO with us today. So thank you so much, Brandon, for finally joining us.
Hi, Don. Thanks a lot for having us.
Absolutely, absolutely. I was telling Brandon before we started the show, I've been watching this company. I see Exyn Technologies at a lot of the shows I attend, and it's so exciting to finally be working with you guys and helping you tell your story a little bit. But before we tell the company story, Brandon, tell us a little bit about yourself first.
Sure. As you said, I'm the CTO at Exyn, but I've actually been here for quite a while. I'm coming up past 8 years now. Maybe one thing that's a little bit unique about me these days is I haven't jumped companies too much. I was at the Boeing company for 7 years before now joining Exyn for 8 years. I worked mission systems, a little bit of R&D software development there, but I had robotics experience and background from my undergrad and master's at UPenn, and was itching to kind of get more hands-on in the robotic space, and ultimately found Exyn. My interest is really in the robotic space. I love drones as well, but the drones is one platform on which we can get our robotics and our autonomy solutions out there into the world. We're excited about ground vehicles, though, quadrupeds, wheeled vehicles. So yeah, that's a little background on me.
I love that. And that's exactly why you guys are on this Mission Enablers show, because it's not just about drones, it's about multi-domain, right? All the robots out there, and we love robots too here on the show, of course. So tell us a little bit about Exyn Technologies. You joined the company about 8 years ago, you said. What attracted you to it? And kind of what's its bread and butter?
Yeah, so my initial attraction was just looking for robotics applications, looking for autonomous applications, and what I started close to home. I've been in Philly for a while. I started close to home, and it just seemed like a great fit. And I was very excited that the team brought me on board. I was employee number 10 at the time. A little bit about Exyn, though. Exyn is a spin out of the GRASP lab, which is the famous robotics lab at the University of Pennsylvania. Co-founded by Vijay Kumar. He was the director of that lab, and is now the dean of the engineering school at Penn. The initial goal of the company was to really to find a way to commercialize the autonomous research the cutting edge autonomous research that was happening there. So it was admittedly a bit open-ended at that point, but we kind of there was definitely some real work that went in there, but we were eventually able to work out a nice fit for our technology. And the mission has been to get critical data to businesses that have traditionally not been able to get the data that they've needed, whether it's because it was inaccessible or it's just too tedious or time consuming to maintain. And we use mobile mapping and autonomous solutions to make that a reality. So we're really trying to push the boundaries with what drone technology, autonomy technology can do to get data to our end users.
Well, I love that you spun out of academia because, I think there's so much great innovation that happens in universities, and kind of bridging that to the commercial sector. It's not always easy, whether it's technology transfer or whatever it is. So the fact that you guys were able to do that and do it so successfully and continue to grow and evolve over time, it's quite amazing. Speaking of amazing, picture paints 1,000 words, and I know we've got a little video to kind of give an overview of what we're going to dive deeper in today. So let's go ahead and roll film.
Since 2014, Exyn has been pioneering advanced LiDAR-based SLAM algorithms, enabling robots to explore and map unknown environments without a pilot in the loop. Now, with over a decade of experience and thousands of autonomous flights in the field, we're continuing to explore with our modular mapping payload, Nexus. Today, recent advancements to Exyn AI, the proprietary algorithms powering Nexus, make it a reliable tool for surveyors and AEC professionals looking to capture accurate 3D models for mapping and inspection. Equipped with Nexus, operators can collect accurate 3D point clouds by hand, mount it to a backpack, or even connect it to a vehicle. And with the additional Autonomy license, Nexus can explore dusty and dangerous environments without sacrificing thin wire detection or obstacle avoidance. Don't settle for the present. Plan for the future and get more done with Nexus.
All right, excellent. We're going to talk a lot more about Nexus, but before we do that, I want to kind of dwell a little bit on this gap that you guys were intending to fill. You talked about mapping, you talked about, enabling data collection in places that are just simply too dangerous to go. And you're doing it through, as I watch the video, right? I'm seeing AI, everybody's talking about AI, using the word autonomy. Can you explain basically how you're filling that gap then with what you're creating there at Exyn?
Sure. Yeah. So we were thinking about our technology early on, and again, how to really be successful with some of the technology the innovations we were leveraging from the Grasp Lab at Penn, and to work with the initial team that we had. And one of the kind of key realizations, and this was particularly true at the time in 2015, 2016, was that a lot of the drone operations at the time were what we like to call automated. So you might have a GPS automated flight where the system would fly from waypoint to waypoint, but you're in open sky. There's really no ability to avoid obstacles, or definitely not moving obstacles. And at this point, you're also relying on GPS or other forms of infrastructure. So what we saw was what we classified as true autonomy here, where it would be completely infrastructure free, and it would really start to act like an autonomous system that you and I would expect. So infrastructure free, we're talking about we were bringing forth technology that did not require GPS to navigate, did not require communications linked to the operator. So in other words, once our system was tasked with a mission, that it could lose connection to the operator and can complete the mission, or some other systems use prior maps to collect, and they'll use those to localize against. We were setting out to do something that was completely infrastructure free in all of those regards. And then looking at okay, well, if we can do this, where can this really be useful? And some great work from the initial kind of business development team. In retrospect, it just when we ended up in the mining space, it was just such a perfect fit. So what we're talking about here is in underground mining, the logistics teams, the surveying teams, they need to know if they blast an area, they create a new cavity, they need to understand the specifics about what was done. So they need to know how much material has been extracted. Was the blast successful? Is it an underblast or an overblast? I won't pretend to be an expert on the specific details of how they're using the information, but understand enough to be able to help out. So in this world, the only way that they could get this information was that they were literally sticking a laser scanner on a pole near where there had just been an explosion, right? So not the safest of applications.
Not by any means, no.
Yes. So sticking a laser scanner on a pole into the cavity to get a map. And the realization was, okay, well, we can use this true autonomy to actually get a laser scanner into that void, see around all the corners that you wouldn't be able to see with a single perspective from the laser on a stick, and come back to the operators. And now we're getting them more information than they've ever had before. We're able to get them further away from the danger area, right? And allow these operations to really be more efficient and more safe. So that was the kind of perfect initial fit. The product that was used there was very different than what we just showed in the video, and we'll talk a little bit more about the evolution for sure. But that was the real original problem statement, and that was our first and still to date our kind of largest successful use case.
Okay, amazing. In the video, it said autonomy level 4, and then it said 4B. Can you explain? I know we're going to talk about this evolution from the origin story to today and this level 4B, but in that context, that what is autonomy level 4? And this original one that you're talking about, what autonomy level was that at?
So the original was the original concepts where we initially we first had users operating the system was autonomy level 3. This autonomy scale is actually something that we developed, sort of mapping off of the SAE automotive spec, but it's kind of more geared towards some of the unstructured environment autonomy the types of use cases that we operate in. So
Okay.
So in autonomy level 3, still a step above the automated flights that we described
The
before,
waypoints.
but still waypoint oriented. So in this case, the difference between a level 2 automated and the level 3 waypoint autonomy is the ability to put a waypoint in what might be another room or what might be around the corner, and as opposed to the system either blindly flying in a straight line to get to that waypoint, or just not being able to get there at all, right? Our system will find the path in the space that you've put it in. It'll find the path to get to that waypoint. So that was where
So
we were
there's
with.
some more advanced navigation, we'll call it,
Yes,
in
yes.
terms of finding, the ultimate location. And what's level 4 then and 4B?
So with level 4, we introduced I'll call it a higher level of abstraction, right? So rather than the user having to strategically place waypoints to get to kind of coax the system to get to the places they needed to get all of the information that they'll ultimately require. In this level 4 context, we introduced a exploration mode. So what this is really kind of our namesake feature here, where now instead of the operator specifying waypoints, they're just specifying a region of interest, and ultimately they want the system to map and access every possible area within that space. So if we go back to that mining application again, you could imagine the operators are there in front of a void, in front of a cavity, and they might not even know the exact shape of what that cavity
Well,
is, but they
especially
just
after a
know.
blast, I'm sure
Exactly.
they wouldn't. Yeah.
Yes. So rather than having to maybe do multiple flights to learn about the environment and iteratively place waypoints, instead now you can place a region of interest relative to the start location of the system and just hit play. And then as I hinted at the beginning, right? So obviously we're deep underground here, so there's no GPS. There's no notion of what the existing environment looks like. And oftentimes these missions, just to give you all a sense of scale, these can be, I think we've flown up to about a kilometer into like an inaccessible area in the mine. So these are
Wow.
going to go well outside of the radio range, particularly underground in these cavernous environments, right? So this will all happen without those constraints. The system will access all of the areas it can, come back to the operator, and then and we can talk more about this later as well, there's a post-processing workflow to refine all of the data and ultimately get it into the end user's systems.
Okay, awesome. Because at the end of the day, it's all about the data. That's why you guys, I mean, that's why Exyn was even created, right? Like, let's find a way to get this data easier and more safely. And this mining use case was a really great first case. And honestly, now when you fast forward to today, you don't have to be in a mine to experience GPS denial. I mean, spoofing, jamming attacks are happening, not just in Ukraine, they're happening every day here. So, it's amazing that you guys like focused on that from the beginning and have perfected it over time. So let's talk about that evolution. Now, the initial product, was it called Nexus or something else? And other than level 3 to 4 to 4B, tell us how this has changed over time.
Sure. So there were a couple iterations of the early product, but I'll call them just the Exyn Arrow for now. And this was it was still a payload, right? So we've never been in the business of making drones. We were positioning ourselves as an autonomy payload for off-the-shelf drones. But at that time, the payload was a specially designed payload for at this time it would have been the M210, the early variant of the DJI enterprise drones. That that worked. We were able to satisfy the mining use case. A little funny anecdote is at one point we saw, or we heard, that one of our customers had, I don't know if it was tied down or taped down the drone to the hood of one of their Jeeps that they were using or one of their trucks they were using in the mine, and they using the same technology that we were using to map these underground cavities on the drone. They used that to map the drive down into the mine, and that was maybe we should have come up with it first instead of having the customer hit us in the face with it. But
Yeah.
that gave birth to the standalone mapping system. So it's kind of using, we'll say, half of what the autonomous payload is on the drone. It obviously doesn't use autonomy, but it's still able to do the mobile mapping aspect and get the data to the customer. So that gave birth to the second product. And what we showed in the video, and this is the current product, the Nexus, was a recognition that this could be done modularly with a single payload. So there's a modular payload design that can snap in with one of our interface links onto the drone. You see it in this image here on a backpack for more manual scanning. We have accessories to put it on now to more properly secure it to the hood of a vehicle. And we've also shown, I think we'll have one image later. We've done some autonomous operations and some manual operations on quadruped Boston Dynamics Spot robot. So we're really leaning into the modularity with this latest iteration of the product, and giving our users the ability to get the data they need in any number of possible ways.
Well, again, smart business decision, this modularity decision, because, I think it was about 2 years ago, even the Department of Defense looked around and said, hold on a second, we need modular open systems architecture. Like, we can't keep buying proprietary systems that only, that we have to keep upgrading and don't talk to other systems. So the fact that the Nexus can plug and play onto different drones, into backpacks, be held by hand. I remember seeing in the video someone kind of holding it, with a handheld scanner as they walk through somewhere. Super awesome. So it seems obvious, but I'm going to ask it anyway. What is the benefit in terms of modularity to the customer, to the operator?
Yeah, I mean, that initial story is really still the best one, right? So rather than our end customers having to buy separate scanning devices or even do makeshift things like strap a
duct
drone
tape
to
drones with your scanner onto a truck. Talk about maybe not a great idea, but at the same time an interesting idea. It's spawned innovation, which is awesome.
Yeah, exactly. And we continue to hear new anecdotes about how our customers are able to use the scanner. I mean, generally we have the form factor that can they don't have to, I'll call it, hack things together, but they can we can kind of find new use cases for the scanning device with the various different form factors we have, or with the different accessories, I'll call it, we have for it to use it in these different modes.
Yeah, I'm going to ask my producer Mike to pop that backpack picture up again, if you wouldn't mind, Mike. So, in terms of swap, right? Size, weight, power. I can see this. Looks like your logo, right? And I'm assuming that's the Nexus in relation to this guy's back of his head. How would you describe, in terms of specs, like the size of this thing, and like you said, the fact that it comes in different form factors?
Sure. Yeah. So we should also talk a little bit about what you're actually seeing there. So our logo is on top of a traditional automotive LiDAR. So we support, we just added support for the Ouster OS1 sensor, which is now that company has merged with Velodyne, which was sort of the original innovator here with the Velodyne VLP16, another one of these spinning automotive LiDARs. So we support both of those sensors. And then we support the Chinese Hesai sensor, which is, again, a similar product. So those are the three different LiDAR sensors we support. That's really the key enabler of the mapping aspect of the technology, right? So this is giving us, depending on the sensor, 300 to 600,000 laser measurements per second, feeding into our Exyn AI autonomy software and generating the maps that our users ultimately use in their workflows. The device also has cameras on it for both real-time and post-process colorization, and then an inertial sensor is another key piece of the localization and the mapping. You talked about the specs of the device. So the device by itself is around 2.7 kilograms, if I remember just right. When we put it on a drone, it gets a little bit heavier because there is it's standard simple mounting, and oftentimes our customers will actually do it themselves. They'll purchase their own drone, they'll purchase our device, and they'll mount the link interface on the drone on their own. That adds a little bit of weight to the 2.7 that I mentioned before. And what else did I leave out?
No, I think that, so the size of it, I mean, it looked like, I don't know, but you said that was on a specific sensor. So
yes,
just,
so that circular piece is the LiDAR sensor there. As you saw relative to the person's head, it's probably around 3 or 4 inches in diameter. I really should. I don't want to. I'm sure we have it on our spec sheet.
yeah,
sure that we can link that
don't
later.
even worry about that. But the bottom line is it's relatively small, and it's packing, like you said, this triple threat. So SLAM-based LiDAR scanning, and with the Hesai and the other company, what was the name again? Because it was like one that bought another company.
Ouster and Velodyne.
Okay,
Yeah.
Ouster and Velodyne.
Yeah.
And the point of infusing all three of these with your proprietary autonomy algorithm is what? It's to create the highest quality 3D mapping solution, or exactly kind of the goal here?
Yeah, so we're really pushing the bounds on survey grade mapping, right? So these are digital twins. These can be for geo registering, right? So if you have sensor data for an interesting example would be, and we've done some demonstrations. This is not quite a product that a bunch of people are using, but you could imagine if you had a gas sensor on a drone, and you're again, let's say, flying an underground mine, or you're flying in let's say, a damaged building.
Sure.
You can use the LiDAR sensor to generate a map of the environment, and then you can register, or you can locate where that kind of critical sensor information is relative to that map. So that's really the space that we focus in. Our systems generally don't interact with the environment, but they provide value just by getting places, right? By getting to places in the environment, mapping it, being able to locate critical data for the end user, and come back.
Yeah, as I'm listening to you, Brandon, I'm hearkening back. I was just a couple weeks ago at GeoGov 25 in the Washington, D.C. area. So it's pretty much the geospatial crowd, but everybody using geospatial data. But of course, a lot of them are also now incorporating drones into their workflows, whether for hurricane preparation or disaster response, all kinds of things. And man, I'm pretty sure this is a crowd that needs to meet you and Exyn Technologies. But anyway, let's talk about this, the workflow. Okay, so we've got the algorithm, we've got the sensors, you've got this small form factor that can be put into backpacks, put on trucks, apparently, put on the drones. Tell us about that kind of back-end workflow. How does that all work in terms of processing, either in the field or when you get back to the office?
Sure. Yeah. So you hinted at a little bit there. One of the nice things about our particular system is that our users are able to get real-time feedback. So while we said that a communications link between the system and the scan device is not required, it is something that our users can take advantage of. So we have a tablet that is used to provide the initial mission spec, whether it's the exploration volume or the waypoints to the system. The system will go and complete the mission for the portions of it that there is communication. You can see in real time a fairly high resolution, very informative map on the tablet interface. And if let's say it does go out of communications range, when it comes back, you can still, while kilometers underground or out at a remote site doing a scan, you can play back and see the real-time map that was generated. And I would like to address in this picture, we talked about that exploration volume. So in the picture you're seeing now, that yellow box that's around this cavity in this mine is what the user would have specified. When they would have started the mission, they wouldn't have known about exactly what the shape of the area was, but they would say, I'm starting here. I know that the area I'm interested in is out in front of me, and they'll draw that box on the screen.
Wow, that is really, really cool. Well, that's a great segue maybe to mission planning. What you guys also have a mission planning mode. I mean, that's what we were just seeing there. What are the different modes that if I was the operator that I could plug in there?
So it is, we found that for more than enough applications and use cases for our engineering team to currently keep up with, just those two waypoint and exploration modes can really solve most of the situations. One that is coming up for us, and we have this is more of an internal thing. We have a proof of concept for is an inspection mode. So rather than in this exploration mode where the system is just it kind of just needs to see for an instant all of the space that it can see within an environment. In an inspection mode, you want to ensure that your sensor of interest is able to, a good analogy is paint all of the surfaces in the area. So you can imagine if you're inspecting a cell tower or if you're inspecting a face in a mine, you don't want to look across that wall and consider it covered. You want to actually get sensor time on target for that whole area of interest. So that's something that we're rolling out in some more pilot type scenarios. But those are the three relevant mission modes of the system.
Okay, so we have, I don't think we were specific, but that's on me. Fly to, walk there, exploration mode, where you're kind of making this box that we just talked about, and this kind of beta, if you will, inspection mode, where maybe I can point out an object and say, paint this whole thing for me. Like I want to know what this whole thing is.
Exactly.
As opposed to just one like volume of space, like a specific object.
Yeah, that's right.
Okay, very cool, very cool. I can see where all of this would be highly relevant in something that a lot of people are heads down on right now, this beyond visual line of sight, notice of public rulemaking, Part 108, the FAA pushed this out August 5th. The deadline actually is looming. It's next Monday. And, there's been a lot of chatter, Brandon. I'm sure you've been watching, people's comments and concerns. This props to the FAA, this idea of kind of a rule that looks to the future and a future of full autonomy. What you're doing in terms of Nexus and some of your other autonomous solutions is looking to that future as well. So how, other than, in the mind that we're talking about, how do you see what you're doing there at Exyn with Nexus and other technologies building towards that future of beyond visual line of sight in every context?
Sure. Yeah. So we've obviously talked a lot about mining. That's again our origin story. But the same type of technology can be used to push into areas that, okay, so outside we started with the automated flight where there's really still quite a few players, and those will still run into challenges. Let's say if you're inspecting under a bridge, or if you're trying to operate very close to a cell tower or other types of linear infrastructure, power lines. You can start to have, the skilled pilots can certainly achieve many of those use cases, but now you're talking about having a skilled pilot on board. That adds cost to get that data. So one of the ways I like to talk about this is, whereas in mining there was no way to really get the data, right? There was the laser on a pole, and that was the only thing.
Yeah.
Now that we've been able to mature our autonomy offering through the years there, we're starting to try to make an impact. We're starting to make an impact in maybe not accessibility of the data, but the ease of getting that data and the cost of getting that data. And that means that you can maybe start to get that data much more regularly. So the bridge inspection, the cell tower inspection, those are probably fairly straightforward. Maybe one that would be a little bit more surprising would be for industrial facilities or manufacturing facilities. Surprisingly, these things can need to change quite a bit over time. And for them to be able to plan out how to, let's say, redesign a manufacturing facility to account for some change in production, or just to plan logistics through the facility, it can be helpful to have a digital twin of that environment that is captured weekly or monthly. And doing that with traditional technologies, with traditional laser scanners, you have to have a skilled operator. You have to have someone there. You have to oftentimes have to have quite expensive equipment to do that, and it can take days to collect. With the mobile mapping capability of the Nexus, so that could be done manually. Let's say that now drives what would have been done with the traditional scanner over the course of days down to a matter of hours. And then with folding in the autonomy on top of that, now you don't even have to have an operator there. So you could imagine having a drone in a dock, or a quadruped, or a dog robot in a dock that one night every week goes and scans the facility. And to make this happen right, we need reliable autonomous systems. They need to be able to handle the real world where things aren't exactly where we left them. And that's really the direction that we're going.
Okay, excellent. And we mentioned AI early in the show. We've been talking about Nexus, but just to foot stomp this, it's your Exyn AI that really powers Nexus, right? Can you elaborate on that?
Sure. Yeah. So there was even some talk early on, is there a way for us to even start as a software company? But we sort of surveyed the landscape and just where the technology was at the time. We needed what was ultimately a payload, and now we have the modular Nexus payload. We needed that to get our algorithms out into the world. But really, the kind of the core of our value proposition is what we can do with that Exyn AI autonomy software. So the form factor that it's in the Nexus is one, but one of the things that we're really excited to talk about today is where we're going with that Exyn AI software. And there's two pieces to this. So the first is that we've recently introduced, and we're working with a few pilot customers, an API for the Nexus. So whereas traditionally we're selling the Nexus directly to end users, the mining customers, the surveyors, the inspectors, by adding an API to the Nexus, we're now allowing partners or integrators to incorporate those capabilities, the autonomy capability, the mapping capability, into their respective products.
Without having the software, basically the module.
Without having so for this specific case, for the Nexus API, they no longer need to use our ecosystem of applications. So they're still using both the Nexus hardware and the software that runs on the Nexus Exyn AI, but they're using the API to the software and to the device to integrate those capabilities into their workflow. And now they will often have with the few customers that we have experience with so far, they'll often have a much more specialized use case, one that we wouldn't choose to focus on with our more generalized product offering. They'll have a specialized use case, and they'll have their own Android app or their own desktop application that will integrate. Well, I guess I skipped a step. They'll have the Nexus on their particular capture device. Some of them are still using it in just manual modes. Some of them are mounting it on ground robotic vehicles. But where I was saying next is, okay, they'll be interfacing with it through their software, which might be keeping track of things that have been scanned in a particular context. I can't give too much detail on these yet, because these customers
I understand, but basically what it's doing is seamlessly connecting the workflow into possibly other people's proprietary systems. So
exactly. Yeah.
Okay, I get it. So you're using the hardware, but this API enables this deeper integration into enterprise, into all different kinds of things. So I know you guys also have an SDK. Explain the difference between this API with the Exyn AI and the Nexus, and then your SDK.
Yeah, so the API was a very intentional half step towards the SDK, which we're going to talk about now, right? So the SDK was, okay, well, now that we have years of autonomous experience with Exyn AI and mobile mapping on our payload, and now we've started to branch out a bit by allowing other partners and integrators to integrate those capabilities, but yes, still use the Exyn hardware with the Nexus. The SDK is now what completely decouples the Exyn hardware from the system. So now, because of the specifics of a particular partner's use case, they might need to use their own hardware. They might have different hardware requirements than what can be satisfied by the Nexus, or maybe it's on a autonomous vehicle that is, let's say, too small to carry the Nexus, or has its own requirements around environmental conditions or whatever it may be. Now they can license the Exyn AI software directly. So this would not have been practical to do right out of the get-go as right from the start, as we discussed, because we were still refining the technology, and it would have been a little bit too much to try to do it once, to have it be as agnostic to sensor hardware and compute hardware as possible, and then also refine the core capabilities at the same time. But we, particularly with the couple years we have now with the Nexus in the field, even more years with the earlier products, and with these few pilot customers we've been working with on the API, we're now in a position where we're starting to talk to, we have a few active engagements as well for SDK deployments. And we're trying to be smart about this. We're being incremental. We're kind of cautiously selecting SDK integration use cases, but we're definitely part of our goal here is if any potential partners out there see a use for our capabilities in their system, we're actively fielding SDK integration opportunities right as we speak.
Brandon, I love that arc, and it just kind of harkens back to the FAA's mantra of crawl, walk, run. Where you develop this aero product, a client basically has this interesting contraption they make that spawns this idea of like, let's build our own, let's build that Nexus, and then over time how that's evolved, and then this API to enable integration with other people's systems, and now the SDK where you're literally exporting autonomy right to people. I think it's amazing. As I also listen to you, I'm thinking when I was in DC, I won't tell you who, but there was a very high level person talking about this use case. They wanted to chase geese away from their lawn. I'm like, oh my gosh, there's this rowbird out there. It's an ornithopter. Have you heard? So Arium Analytics out of Canada makes this thing, but it requires a pilot right now to fly it, and it's not easy to fly, from what I understand. So to have this SDK in the rowbird, I got to introduce you, because this rowbird, some of the clients are talking about like mining or like, the tailings ponds for oil and gas folks, energy sector.
Yep.
If a duck or bird falls in that thing and dies, like that's a big fine for them. So that's where they're using the rowbird to chase these things in an environmentally friendly way. Just get them out of there. But right now it's requiring a pilot. Like, what a perfect use case for that. So really interesting what you're doing. I'm sure there's tons of people out there, and that's really maybe a great bridge to my next question, which is, as you're talking through this, all the different things you have going on, who are the key stakeholders that you guys would love to engage with? In other words, what's your ideal market? Sure, there's more than one. Mining obviously is one. And who are the other stakeholders that you feel could deeply benefit from all the things you're doing there at Exyn?
Sure. Yeah. So as for the autonomy aspect specifically, we are trying to be careful about finding the highest value add, right? So applications that can be solved by a manual pilot are still interesting, but the ones where it takes a really skilled pilot, or it's just so time consuming or cost ineffective to have a manual operator there to do the work, are the types of use cases that we're honing or zooming in on. And forgive me, a lot of the same types of industries that I've talked about to date, but the industrial manufacturing types of routine scanning, where you're doing periodic scans. Maybe one that I didn't mention is in construction. a similar type of idea here, where maybe, let's say, as you're building a new building, or you're any type of large construction project, right? The earlier we find issues relative to the design, the much cheaper those are to address. So
Absolutely.
having autonomous systems, well, again, the autonomy is what's making it cost effective and practical to get the data, but then having a system that can get you ultimately that digital twin of your environment in real time, let's say over the course of a months or years long project. From a business perspective, we see that as being very valuable for our end users, and with the capabilities that we've been developing here at Exyn, we think we can make that a reality.
Yeah, I mean, that makes sense. I know I've seen you guys at Geo Week, it's the big ACE crowd, right? Architecture, construction, engineering. But you mentioned other use cases like inspections, and that makes me think enterprise, energy sector,
Yep.
critical infrastructure. I mean, I think the list is really endless. And like you said, Brandon, I mean, in terms of where can this make something more safe and regularized, where it's not just one pilot flying one drone in one place, that's where this is going to make a difference. So as I knew would happen, we're getting short on time, and I want to make sure we talk about what's next. You've kind of alluded to it. You're working with companies on this SDK. You're rolling out the API. People are out there now using the Nexus, the modular Nexus. What's on the whiteboard, if you will? Like what's coming up?
Yeah, so the API and SDK are definitely the biggest things, but I'll try to quickly cover a couple other things. So the drone that we operate on most often is the DJI M350, soon to be M400. But back to that modularity of the Nexus, we're constantly integrating new platforms. So we have support for the IF800. We're planning to I won't announce now, but we're planning to announce over the next couple of months integrations for additional US platforms. And then not just drones, but we talked about Boston Dynamics Spot. We're also looking to push the bounds on what we're doing with ground vehicles. So this is a little bit further out, but we as I've said, we've done some demonstrations with ground systems. We're making an internal push to get our ground autonomy to the same level of parity as our aerial drone autonomy. And in conjunction with that, we're looking to release support for additional ground vehicles. And yeah, I think those are the big things. There's kind of always things to refine and to harden on just the core capabilities of the autonomy software and the mapping. Customers, there's no such thing as or the customer can. There's always an opportunity to make it just a little bit more accurate. So we're pushing the bounds of what we can do there as well, just on the data products that are going to our customers. Yeah.
Yeah, I agree. I think with technology, there's no such thing as kind of mission complete, right? There's always going to be some new iteration, some new use case, some way to tweak it to help, maybe even something you weren't even thinking about. And I know in terms of how people can find you, you guys are going to be running around the Reality Capture Network, Archon this week. I think it's this week.
Yeah,
Or
that
was it?
started yet.
Yeah.
It started yesterday through tomorrow. We have a team member there. We'll be at InterGeo in Germany. I think that's next week, and then Trimble Dimensions in Vegas. I don't remember the exact dates on that one either, but definitely coming up.
Yeah, very, very cool. Some of those, I hope to get to Archon maybe next year. I'm actually going to be on the recap podcast upcoming. I was working with Ellis Malmgren from RCN, and met those guys at Geo Week last year. So they're doing really cool stuff. I love that you're working with them. All right, so how can people learn more? How can they reach you? How can they find out more about Exyn Technologies?
Sure. So our website, exyn.com. Please reach out to me on LinkedIn is the best way to get in touch with me. If you're at Archon and you want me to help you get in touch with our teammate out there, and you happen to be watching this live, I'll be happy to get you in touch. And yeah, that's the best way to do it.
Okay, awesome. And then any closing comments for the audience as we dial off?
Yeah, so I did my best, but it's always tough to describe what this technology can do, even in just in a podcast format like this. So I encourage people to check out our YouTube channel. There's quite a few videos there that show off this exploration capability, the sheer volume of the real-time data you can get on the environment that you're in. So I think that's a good place to go. And then I want to plug again on the Nexus API and the SDK for any potential partners out there. We're very excited about this direction that we're going. We see a pretty big opportunity here to ultimately get Exyn AI software into more places and to get data to the people that need it. So please reach out and let us know if you think there's a good opportunity for us to tackle together.
And I also recall that you guys schedule demos. I think there's a link to schedule a demo on your website as well. So that's just another great way to get an up close and personal on this technology. So, well, thank you so much, Brandon. It's been wonderful talking to you today, learning a bit about Exyn Technologies, your journey over time, and kind of where you guys are going. So I love all the autonomy you're bringing to the world, multi-domain, not just drones. So thank you for what you do for making so many different markets safer. And that's all she wrote, everybody. Thank you so much. We are out here.